You gave a correct statement of how I ended up here. I didn't used to be in this field at all. I got interested in machine learning because of an interest in automating medicine, which is crazy broad, but then the language side of mental health brought me to natural language processing. Plus, it's just amazing. And then all kinds of things started happening that we've all been exposed to. And so that's the reason I'm here. It is remarkable, and in fact astonishing, what textual generative AI can do compared to what was just possible 2 years ago. You can ask questions and get deep answers, like what is a concept? I think concepts are really important in this world. And so for all of us, and me included, it's always interesting to contemplate, what's going on under that hood. Who are you talking to when you're talking to that thing? And everybody's talking to it. So I hope this is helpful. But one thing to realize is that the researchers that created this thing don't really know why it's so powerful. I'm going to show you one of them, actually. Even though it was engineered into existence, and so I can tell you some things that I will about how it was made, and people are gaining control of them in certain ways. It's a very complex and opaque black box that requires that we study it empirically, like biology and medicine. No longer can you write math that actually means something or prove an awful lot, although there's a lot of math in the field. There's not much to prove. So you have to study things empirically, with the advantage that you can build different versions of these things, and you can probe them without getting ethics approval because they're not yet sentient, and so you can look right inside them far more deeply than you can with biological entities. And so there's things that can be learned, and I think there's the rate of publication going on right now is enormous. There are thousands of papers coming out monthly that talk about all aspects of these things that it's very hard to keep up with. As a new person in the field, I actually think that gives me an advantage because everybody else is struggling to keep up. So where I'm going to start is just at the very beginning of the basic process of text generation. And let's ask ourselves, what is ChatGPT? You've probably heard that it's called a large language model. What is a language model? Well, you see it every day when you're texting. Given a sequence of words, when is the next? Your text app, here's mine, would suggest one of these three words. What is the next time? When is the next one? When is the next episode? So a language model only does that. It predicts the next word. It's large meaning the big ones are north of 175 billion parameters, numbers that get set when it's trained in the artificial neural network. That's a lot. That's a big number. It's hard actually to compute that many things. That's one thing that makes the field difficult. You need a lot of compute power. You use a lot of energy to do these things. The other large is it's trained on hundreds of billions of words. And by the way, this presentation is full of ChatGPT generated pictures. It's amazing. You just ask for it and you get it. And then if you don't like it, you say fix it. It's incredible. It is important to note. Hands up, who's touched ChatGPT? Hands up, who pays the $20 a month to get on the good one? Oh. But then that's a mistake. It is worth, at least for 1 month, you should be paying $20 because the GPT-4 one is a lot better. And you get this too, these great pictures. But, I mean, there's lots of ways to get these pictures. The pictures have become very good. So a language model. The input is words in a sequence, and the output is just the next word. Been doing that on your text a long time. So if the input was the sentence, the partial sentence, the clean river flowed, then that goes into a neural network, and maybe what comes out is into. The clean river flowed into. Makes sense? So how does one word turn into many? It's sort of, you just take that new word, you make it part of the input, and you generate the next one. So if it was the clean river, that makes lots of sense, maybe, but I'll just illustrate it. Maybe I'm belaboring it here. If the initial input was the clean river flowed and the prediction was into, then that gets put into the next input, clean river flowed into, and then the next word that's predicted is the. And the clean river flowed into the lake. And so you get a sentence. It just keeps going. I don't know if it's this, I'm not sure this is useful, but some terminology, whatever the input is, that you put into a ChatGPT. It's called the prompt. The model produces just the next token. And so I'm only going to talk about tokens on this slide. A token is a piece of a word, roughly 3/4 of a word. Yeah. And you pay per token if you're using certain versions of the model. And so you append the token to the prompt, and you get a new prompt that predicts the next token, and so on. This has a fancy name. It's called auto-regressive prediction, when you take the output and predict again from it. You might ask, how does it stop? There's a special token called stop that it will stop predicting after that. Or you can just put a hard limit and say, I only want this many tokens to come out. And that's the last time I'll use the word token. I'll just use the word, because that's close enough. So I think it's helpful to try to get a sense of how these models learned what they learned. And what we want it to do is to predict the next word really, really well. And let's just pause on that. That's at the very core. We want the model to be really good, that the word that it's going to produce is correct. And the way we train it to do that is we show it lots of examples of words and ask it to predict the next word. So we give it a sequence of input words and ask it to predict the next word. If we know the right answer, we give it a grade, just like we all give our students. A high grade if it's good, a low grade if it's bad. And that grade is then used to transform or change the parameters in the network, 175 billion or more parameters, so that the network moves towards the right answer. The strange thing at the very beginning that I still find unusual in all these neural networks is the parameters start out as random numbers. They don't know anything. They know absolutely nothing. And then they produce a prediction, and then this process of grading them, just like we do for our students, changes those parameters in the right direction after all kinds of clever thinking to make it better. Yeah?
This grading process from the start sounds horribly time-consuming. Was this done manually, or it was...
Yeah. Question is, who does the grading?
Yeah.
The computer does it automatically. And I'll show you why we know the right answer. Oh, we know the right answer. I'll show you in a second why we know the right answer. So maybe that was your question. How do we know the right answer?
Well, no. It was how is it graded? And if it is done by a computer, how does it know the right answer? How does it know an answer that's okay? And how does it know an answer that's completely wrong?
Yeah. I'll get to that in just one second, how it knows the right answer, and I'll try to push into those other questions. However we do it many times, over and over again. So it goes from something that knows nothing to that it works really well. And so here's the examples of of training, just to be clear. You take a written sentence, any written sentence, and you might say, give it the two words, the quick brown fox jumps over the lazy dog. So you'd start with the quick and say, predict brown, because that's the right answer for this sentence. And then because you've got lots of other examples built into every sentence, the quick brown, you'd put in the quick brown, and then you'd ask it to predict fox. And if it gets fox, then that's a good grade. And if there's lots of other choices it could have predicted, and what is the right answer? I guess the right answer is it looks to your question, what is the grading? It knows the answer's fox. There's lots of possible answers. The computer focuses on the output that says it's actually the probability of it being fox. If that probability is low, then the grade is low. If that probability is high, the grade is high. Now, so that can be done automatically, and so on. This is built on a revolution that started here at U of T in 2012. There's a famous paper by our colleague Jeff Hinton and his students, and Alex Krasinski and Ilya Sutskever, that launched the revolution, showing that neural networks are quite capable of doing things. Before that, lots of us, including me, made fun of them and said, that's stupid, doesn't seem to work. Yes, it has a great hypothesis, but it never really worked. But then it started working better than anything people had done in the original field, computer vision, better than the experts had done. All of a sudden, 15% better, and then that just made everything took off. So that's one thing that had to happen. Another thing that's I still find deeply fascinating is the second thing here, that meaning can be represented in a set of numbers. You could take a set of numbers, say 50 of them, and take every word and translate those words into a set of numbers such that the meaning is represented there. What does that mean? What does it mean to have numbers represented in meaning? It means words that are closer in meaning have sets of numbers that are closer together. That's at least the first piece of what it means to represent meaning in numbers. There's other amazing subtleties that if you're interested in, I would urge you to go to the first lecture of my graduate course, ECE 1786. That whole first half, that whole lecture is about this concept of meaning being represented in numbers. And that's revolutionary in a deep, deep way, because once meaning is represented in numbers, everything else that's happened became possible. Before that, you had to have code that said, oh, that's cow. I know what cow means. If a cow is next to a pig, maybe it's a farm. Somebody had to write code for that. That all goes away when meaning can be encapsulated in numbers. So that's a crucial and brilliant innovation that's been around since the 60s, but in the neural network world, it became way more powerful. Yeah.
Maybe this is a foolish question, but when you say meaning, do you mean word meaning?
Yes. Yeah, word meaning. Yeah. Yeah, I can't resist. Here's another thing that you will see in that lecture. So I'm saying if you've got two words like strong and hard, those two words are close, and so the set of numbers would be close together. Literally, you just subtract the sets of numbers, and the difference would be close together. But that's not the only thing. That once you use neural networks to produce those, here's the classic one, which some of you may know. There's a set of words, a set of numbers for the word king, and for queen, and for man and woman. If you subtract queen from king, you get the same as you get subtracting woman from man. Whatever the difference is in sex or gender is encapsulated in that difference. So there's pairwise things. This is kind of stunning. When I first heard this, I went, well, that's crazy. How could that be? But there's a whole pile, and by the way, aunt minus uncle, sister minus brother. You subtract those, you get the same, whatever that is. Just stunning. But also Paris minus France is equal to Ottawa minus Canada. And all kinds of pairwise relationships like that. So it's quite stunning, yeah.
So related to sort of, I guess, the gender thing that you're playing at, like I think you said strong and hard are correlated. But what
I just tried to come up with two words that were close together, yeah.
Yeah, but in my mind, strong and soft are correlated.
Yeah, they probably are.
So I wonder how the meaning, when you reduce meaning to numbers, what gets lost and what gets like amplified.
Whose correlation?
Yeah, no, well, where does all this come from? It's
Sorry, it's a different question.
It is a different question, and it is deep, actually. It's a beautiful, deep thing, the representation of meaning in numbers. And you can ask a million questions like that. And you can look for all kinds of biases that you'll see famously. Yeah, if you go to that lecture, you'll see in the old, they're called vectors that represent these things. There's all kinds of biases, and there's been all kinds of work to try to remove them. Didn't mean to spend so long on that middle point, but it is amazing. Meaning in numbers is just incredible. A third thing that happened that caused ChatGPT to come along was this neural network called a transformer that seemed to just be a better way to do things. That's what my course teaches, basically. It's how does a transformer work. I'm actually skeptical about a lot of the things that are said in it, but a ton of it is really important. So, but that's not the topic for today. So I think I've said this, but I'll say it quickly. The other thing that had to happen is the networks had to you had to make them big. So very large neural networks, and you had to train them on many examples. Oh, I did hear a great anecdote. I was listening to A.J. Agarwal, who's a professor in the Rotman School, talking the other day, and he seems to be very well connected into the AI world. And he told the anecdote around this point of big, that talking to Ilya Sutskever, PhD graduate from here, quite famous as he was involved in the drama that happened at OpenAI, if you were following that a few weeks ago. He flip-flopped on it, but he's a really brilliant guy, and I'm going to show you him later on. AJ said he was talking to Sutskever around 2017 or 18. That was the moment in time when Microsoft invested $1 billion in OpenAI. And AJ said, he asked Celia, what are you going to do with that $1 billion? And apparently Sutskever said, I'm going to make a bet that if you make it bigger, it gets better. And it did. And that's why we're here today, actually. So a bet, $1 billion bet, because you need that much computation to kind of figure this out. It's kind of amazing. Oh, and this is really important, sort of to the point. How do you know the right answer? It's in the sentence. Everything ever written gives you the right answer. And that is unique in the world of machine learning. It's actually hard to find the right answer. Often humans have to go and figure out the right answer. What's in this picture? Or what is the prediction that you wanted to train the thing to do? You don't have to do that in the language world. The right answers are in everything ever written, assuming you think what's written is worthwhile. That can be a problem. You should probably have permission of the things you train on. That's still to be decided in the courts. And everything ever written represents all aspects of humanity, both the good and the bad. And so there's lots of work trying to, there's lots to talk about on that, but this was key to making the success. So all of this is about predicting the next word. Predicting the next word could be easy. If I have this sentence, the door was, what should it be?
A jar shut.
A jar opened shut. Yeah, it's easy. Everybody's got a good answer to it.
Ugly.
Say again? The door was ugly. Absolutely. Pretty straightforward. But there's lots and lots of text out there that we have no expertise on. This I pulled from a dental thing I Googled. Once the metal implant post is placed in your jawbone, osseointegration begins. During this process, the jawbone grows into and... Anybody got a clue? Absolutely not. And unites with the surface of the dental implant, of course. But if you got good at predicting that, you would know a lot. And that's the secret here, that it isn't just about that the act of predicting the next word, when there's lots of words that come before, you have to know all kinds of things. Like you have to be a specialist in everything. And remember, it's trained on many, 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 many things. So you need to know a lot. So some history here. I actually encountered GPT. We started using GPT-2 and we're amazed at what it could do back then. It spoke coherently and everybody got really excited. It didn't say the right things. It just spoke coherently. But we fine-tuned it and made it do the thing we wanted to do in our therapy work. GPT-3 came along in 2020 and began to do what it was asked. And GPT 3.5, which is the thing that the original ChatGPT was based on, did what you asked. And GPT-4, which is, you're going to have to pay that $20 to get access to, does it much better. And so it's worth looking at. And this is the 234 is the size growing in a big way, and the amount of training growing in a big way, and the amount of data training in a big way. And this kind of shows that progression. This came from the GPT-4 paper. These, you can't read it, sorry. I always criticize people who do this. If you were to look at the x-axis here, you would see these are different tests, AP Calculus, the LSAT, AP Microeconomics from high school, and so on. And the blue score is the score that GPT 3.5 got, and the green is how much better GPT-4 is than GPT 3.5. So a bunch of these things got better. It is interesting that AP English is really, this one right here is really low. It's ironic, really. So English, not so good.
And English language, just 3 to the right of them, still is also not great.
Yeah, which is kind of interesting. So that's pretty remarkable, actually, and you probably heard that. That was part of the news that came out in March when GPT-4 came out. That's Ilya Sutskever talking to Jensen Huang, who's the president of NVIDIA, if you've heard of NVIDIA. And I want to share with you just a few minutes of what Sutskever says, because I've heard him talk a bunch of times. And this minute is compelling. I'm not sure. I'd be curious to know if this works for people. Let's see if this is going to work. You can see him. So he's going to talk about the thing I just said about predicting the next word and what's going on when that happens. Oh.
Well, back then I was starting in 2002, 2003.
Oh, no, sorry. This is not starting in the right point. Pardon me.
Masking and other.
I did not go to the
there
right.
was a very.
It's a competitive sport.
Yeah, right.
Oh.
You need to be smart. You need to have fast. You need to
Okay,
have,
you can't even hear this. Oh, that's too
the
bad.
question is
there a volume?
what to use it.
It looks like the HDMI. I've got my HDMI plugged in, but for some reason it's coming out of my computer. I don't know if there's a way to fix that. Give me 1 second. Well. Oh man, these things are getting too.
There should be a source volume control on your.
Yeah. Sound output.
Press strong.
That's what we want. Yeah, that's better. Okay, and now let's go back. I think this is it. Let's see if this works.
About is that when we train a large neural network to accurately predict the next word in lots of different texts from the internet, what we are doing is that we are learning a world model. It looks like we are learning this. It may look on the surface that we are just learning statistical correlations in text. But it turns out that to just learn the statistical correlations in text, to compress them really well, what the neural network learns is some representation of the process that produced the text. This text is actually a projection of the world. There is a world out there, and it has a projection of this text. And so what the neural network is learning is more and more aspects of the world, of people, of the human conditions, their hopes, dreams, and motivations, their interactions and the situations that we are in. And the neural network learns a compressed, abstract, usable representation of that. This is what's being learned from accurately predicting the next word. And furthermore, the more accurate you are at predicting the next word, the higher the fidelity, the more resolution you get in this process. So that's what the pre-training stage does.
So that's what I've been talking about. I'm about to talk about the thing he's going to talk about, but I like the way he does it. He's going to say the pre-training, the predicting the next word, that's where a lot of smarts comes from it. But then there's another step that turns out to be important, and I like the way he describes it. I think it's better than what I'm going to do, so let's listen.
This does not do is specify the desired behavior that we wish our neural network to exhibit. You see, a language model, what it really tries to do is to answer the following question. If I had some random piece of text on the internet which starts with some prefix, some prompt, what will it complete to? If you just randomly ended up on some text from the internet. But this is different from, well, I want to have an assistant which will be truthful, that will be helpful, that will follow certain guide rules and not violate them. That requires additional training. This is where the fine-tuning and the reinforcement learning from human teachers and other forms of AI assistance. It's not just reinforcement learning from human teachers. It's also reinforcement learning from human and AI collaboration. Our teachers are working together with an AI to teach our AI to behave. But here we are not teaching it new knowledge. This is not what's happening. We are teaching it. We are communicating with it. We are communicating to it what it is that we want it to be. And this process, this second stage, is also extremely important. The better we do the second stage, the more useful, the more reliable this neural network will be. So the second stage is extremely important too. in addition to the first stage of the learn everything. Learn as much as you can about the world from the projection of the world, which is text.
Now you could.
So, does that make sense? I've heard him on podcasts and stuff. He's very compelling and in the insightful, careful way he describes things. And so, yeah, I encountered that the other day and thought it would be interesting to show here. So he talks about, projection of the world. That's kind of fancy talk. That needs some thinking. I think about it, I joke that when we don't understand something, we say it gained emergent properties, and it did. It really did. It seems really clear to me, and I think others agree with this, that there's an ability to do higher level inference, to abstract basic things into higher level concepts. I feel that's very much what's going on here. And here's me saying what he said in that second thing, that there isn't just that predict the next word thing. There's another layer of training, and I like the way he said it, that it's got they call it reinforcement learning with human feedback. It's quite clever. Here's a GPT-4 picture of that. And they take ratings from humans to judge what came out, to make what comes out better, basically. Like the grading is based on what humans think at that point. And so, actually, to your question earlier. What I find a little bit interesting about that, you can't just go to it and say, produce what humans like. You have to keep it anchored to what it knew. And so that's what this picture means. You have to keep both things in play. And so that's as much detail as I would go into it. This approach is also what they use to remove bias, to remove the toxic outputs, to make it not produce dangerous answers like how do I build a bomb and that sort of thing. That said, we've been reading papers in my research group lately that people have cooked up really clever ways to circumvent this, really clever ways. So just put a string of certain characters on the end of your request and you can defeat the guardrails. So the only other place I was going to go was, you hear a lot about hallucinations, which is the term that, not so good technical term, it says that ChatGPT can produce things that are completely wrong. And it certainly is not correct all the time. And it's maybe a bit useful to know why. And the answer is it's gambling on every word. And what does that mean? Well, I lied earlier on when I said the next word is predicted. It doesn't predict the next word. It predicts the probability that across all possible words that word will be selected, is the right word. So remember I said if it was fox, it was looking at the probability of fox. So it does that for every word. Every time it's producing a new word, it is producing a probability across a 50,000 word vocabulary. It's not really words, it's tokens. And so this is the correct picture. The clean river flowed, and then starting with aardvark, going down to zebra, it produces a probability that sums to 1. So that's the truth. So that means you need a method to take the probabilities and pick a word. What's the obvious method? Yeah, pick the highest probability. Turns out that doesn't work. You get a very boring set of answers. You have to do something else. You get very simple, short answers if you just pick the most probable word. You need diversity. So this is called decoding, the problem of, given the probabilities across the vocabulary, pick one of them to be the next word. And you don't pick the highest one. And the current method, which just begun to think in the last couple of weeks, this will change, I think, someday, this decoding method, to something that's far more clever, because this is going to be surprising if you haven't heard it before. So given the probabilities across the vocabulary, select one of the words. You can't search through all possibilities, because this is what all possibilities look like. The clean river flowed could be in, through, to, and all possibilities mean you kind of have to chase down all subsequent probabilities. And this is just a small tree of possibilities, but that I've drawn. But if at every point there's 50,000 possible answers, and each computation is quite expensive. So this is out of the question. You can't look across all of them and pick the highest probability answer of the sentence or the paragraph that you want out. So this just doesn't work. So instead, here's what we do, and this is surprising. We roll a weighted die to select the word. And the die is weighted by the probabilities. What does that mean? It's a bit confusing, actually. So let's make it simple. Not 50,000 possible words. Let's say there's just 3 possible words to understand. Up, down, and left. That's the vocabulary. That's the only words you get to choose from. And let's say the probability generated by the network of up is 0.5, of down is 0.3, and left is 0.2. Sums to 1. And so we want to roll a die that will select up, like with the probability of 0.5. There's a 50-50 chance that you'll pick up, a 30% chance that you'll get down, and a 20% chance that you'll get left. So that's what a weighted die looks like. It's got cork in a certain way. How do we actually do that? Well, here's a little bit of an algorithm. We're going to generate a random number. You can make computers do that. It's easy to do. We get a number between 0 and 1. And then if we think of the probabilities this way, up is 50, down is 30, left is 20, and you kind of put them on a scale like this. If you can generate a random number between 0 and 1, then you look at the random number. If it's less than 0.5, you pick up. If it's between 0.5 and 0.8, you pick down. And if it's bigger than that, you pick left. That's what happens. That's what's happening every time you're getting each word coming out. It's rolling that die and picking those words. It's kind of shocking, actually. But it explains why you get some really stupid answers, because there's a tiny chance that a really stupid word starts things off, and you get what they call hallucinations. But it's good to know that's how it happens. There's a bunch of parameters that you don't see in ChatGPT that you will see in other interfaces, where you can set the temperature. Brian.
That's right. Just one thing that follows directly from what you just said, but presumably if you ask the same question again, you'll get a different answer because of those probabilities.
That's absolutely correct. If you rerun something, you will likely get a different answer, unless it's the first. There's a high probability that the stream that's going to come out is
very possible.
Yeah, and in fact, it's a huge advantage. And I'm going to talk about that in a moment. This disadvantage is it just says things that are wrong. I don't know if it's an advantage, but I'll get to that in a second. There's ways to control what comes out. If you pay money in a different way, you can get access to something where you can set something called the temperature. If you want to turn up the temperature, it'll become more diverse what it produces. And so, and it can get really wacky, actually, more likely to be wrong, but also more kind of inventive. And so that's interesting that you don't see that in the ChatGPT interface. This is the GPT playground, and this is a screenshot from it. And you can see I typed in the clean river flowed. And this one has you see it there? Let me grow it. You can see that you can turn on a mode that shows the next word. So I think I was highlighting this word. Yeah, down. And so down had the probability of 17%. Through had the probability of 12%. I don't even know. Cal is a piece of a word. I'm not sure what that's going to be. It's all these different probabilities. And so you could actually ask it to see that probability distribution for those words. Yeah, Jane.
Can you back up and explain temperature?
I didn't explain it very well, other than to say that there's this parameter you can set, which, can you see it over here? Yeah, see it over here? You can see it. You don't see this in ChatGPT, but I can play with it. It defaults to 1, which means ordinary temperature, I guess. I could show you an equation that changes the probabilities in a way that behaves like this. When you make t bigger than 1, it sort of shrinks the differences in the probabilities. If there's one that's a big probability, it starts to get smaller, and the smaller ones become bigger. So that makes it more likely that something different would come out. It's an equation that has that property. Yeah. So to Brian's point, if you don't like the answer you get, you can push it and try again. And that's super powerful. That gets used in the training as well as there's lots of reasons to think, if this is an imperfect system, you can run it automatically multiple times, and if you have a way to judge what's coming out, you can pick a good one. So that's handy. Yeah.
This goes back to the classic maxim of Michael Collins that you have to know the answer to get the answer.
That's very interesting. Michael Collins said you have to know the answer to get the answer. That would be true. If you generate multiple ones, then you have to have a method to choose them.
But how do you know you want to run it again, right? I'm thinking of my students making use of this, and they get an answer that looks like an answer to the prompt, but may not have.
There is an answer to that that's showing up right now, and in fact we've been using it in our research, and you're not going to like it. In a way that actually seems to work is that you use another instance, call it another run of GPT-4, and you tell it what makes it. You give it some criteria for a good answer, and you ask it to judge itself. And that looks like it actually works, because the models know a lot, and sometimes when they generate, they don't get it right. But then you can ask it, is this good? And you could ask it, are all these which of these 10 are good? And you have to validate that, right? So we're scientists here, right? And if you build a tool like that, you have to validate it by testing it. And I have another talk actually that's kind of about that, if you want to hear that. So that's one way you can automatically do it, but it takes some work to make a tool that validates. It depends on the nature of the answer that you're talking about, whether you can build something, whether you know enough to train it to, or tell it to tell you if the answer that came out was good. Yeah, Lisa.
When somebody regenerates, so I say, I have give me another answer, like regenerates, and then eventually you stop, presumably because the person has found an answer that works. Does that information get coded into those weighted probabilities, or are those two things?
Yeah, so the question, if I can just repeat it, does when you ask over and over again for different answers, is that part of the training? The answer is no, it's not. It's just the output, unless, and here this comes down to the license and so forth. Depending on which version of these systems that you use and what their license says, they will tell you whether they'll take your inputs and use them for training later on, and they would probably use the outputs as well. They probably would. So, but not in the basic system. It does not automatically take that in. It may appear to you that it's learning from what you've said, but that's because it keeps that is kept around, and it's always looking at everything that was said. You say something, it says something. That's always going back into the model, and it's producing the words one at a time. So there are many. So you get different answers. And I think the fact that you get different answers represents a truth in language, that there are many ways to say the same thing, and there's also many answers that could be different to the same question. Look at the political world as it stands now. There are a lot of different views on things. The bad part is, if you get started on the wrong words, you get an unlucky roll of that die, then you get nonsense. And so, our students sometimes don't get that. In fact, even I would say I'm looking at stuff and I may go, I don't really know if that's right or not. I have to go find some way to verify it.
So let me just back up.
Yeah.
You had said that it doesn't keep or the iterations that it's gone through.
To learn from.
Okay. So
Unless there's another process undertaken by the company that you're paying to do this, or not paying. If you're not paying, maybe they are doing it. They may keep it and use it, but that's a separate process.
And the reason I was asking is if an answer came out that a student was like, I don't know if that's right or wrong, if they basically Googled what came out, it would not pull up ChatGPT's own iterations to say, oh, yeah, here it is, you're right, or does it?
No, would it Google what came out? No, I don't think anything that I don't think that anything that's going on now causes what comes out to be placed on the internet. I mean, the internet is a place that you have to do something specifically. who knows what's going to happen. Now that you said it, I'm wondering imagine somebody put one on the internet that did exactly that for some reason. Who knows what's going to happen? Yeah.
It's interesting. That's why we keep talking to you.
That's fine.
I'm in the middle of grading right now. I'm trying to apply this to grading. So I have a rubric, and the rubric is kind of like what I think is a good idea. But we're talking about leadership, so there's no correct answer. And some students are very good at identifying how to write an essay that will follow the rubric, even independent of using generative AI. But then they're not doing the thing we're trying to get them to do, which is listen to themselves and connect with themselves, right? So for leadership, you can lead according to my values, but that's going to be really effective for you. So what I'm doing is I'm sort of grading by my rubric, and then I'm like, oh, and then this student did something that was way smarter than what I would ever have thought of, and I want it to be higher, right? But then ChatGPT would mark that as lower. So how do you foster creativity, innovation, and leadership for this kind of course, right? And I think it would be easier if I was grading a calculus exam, although even then, a beautiful proof might be much more beautiful if the student came up with it.
I think, correct me if I'm wrong.
I'm just always trying to apply something to what I'm doing right now, and I'm in the middle of grading reflections.
Yeah, and one thing that I'm leaping to that you might or might not be, which is that you could use GPT-4 to grade grade those things. You could, and you could hand it your rubric. But in addition to that rubric, whatever you said that was your world or your values, you could say also, this is only one example of the values that you could express. There may be many more, and many are legitimate. Anything you can say in English, you can expand your rubric. I mean, you didn't write that in your rubric, right? You said something more narrow than that. If you wrote something that was broader than that in English to model here, and here we're not talking about generation. We're talking about using one of these things to judge the student's work. Yeah, if you can express it, it might do it. Now, here's where you have to validate. If you were going to do this, you would have to have a bunch of test examples, including the one that's out of your personal scope. You'd want to see if that actually worked, and so and it might actually. In my grad class, a lot of the students in their projects were doing this, and we put them through this process where you go, yeah, you can use this to validate the other things that happened, but you better prove that it works with at least some number of examples, and so. I don't know that. Were you asking about using one of these things to do the judging, or?
To do that because I like to connect with the students, but I was trying to imagine ChatGPT in a way that would be applicable to what some of us are doing.
Yeah. So you could consider absolutely using it. The talk I'm going to give actually on Wednesday is going to talk a little bit about. I'm trying to use the right language in a discipline that's not mine, but maybe yours actually. Coding of qualitative answers. I think you can use this thing to do coding of textual answers. That is big labor and painful, and I think that's a big deal for everybody in the social sciences actually, and anybody who wants to process text. And that's not that different. Coding is marking maybe that kind of coding, and so. I think it's possible. I think you have to experiment to find out how well it works. Yeah.
Just kind of related questions. When you say choices here, that's human language use, right? So if you're talking about ChatGPT, the word choice is like chance. Right?
In the current.
When you're talking about coding, you're narrowing the chance of choosing something that having something random that I would choose, right? So it's not. So it would be the you're narrowing the chance that reflects what a human might choose or would choose. Is that like a way of understanding that?
Yeah, it is. I think the thing I'm about to say is going to go somewhere towards what you're asking. Yeah. So, yeah, you're predicting ahead. That's very good. Yeah. Yeah, go ahead. Yeah.
So I have two questions. I hope that's okay. So what body of words would taken to train it? And what happens to our day-to-day search? So I would imagine if it was based on short encyclopedias or something lesson, that might be updated now. So, kind of what body it was
So why don't I try to answer that, and if you can hold your second question, because I can't hold two questions in my head. The body of words that was used was, I mean, you can go look it up for each one of these models. They say there's a thing called a model card. So if you Google GPT-4 model card, you will see at least some broad statement of the source of the text it was trained on. It's Wikipedia and everything they could scrape off the internet the first time around. After that, they started trying to make it, they realized that the quality of that text actually matters. And so the other models that have come along from other people have, they've been more careful about what text they've been pulling from the internet. You wouldn't want to pull off the dark web, I don't think. And it is dated, absolutely. For a long, long time, it was September 2021. Anything after that is more likely to be absolutely wrong because the models were trained on things before that. Now they're being updated. So I think more recently, there's a more recent date that GPT-4 has been trained on to predict. Doesn't mean it really knows it, but it's been exposed to it. So absolutely, the dated nature of the text is an issue. There are other ways to deal with things not the model not knowing what you need it to know. I could go into that, but I'll let you ask your second question.
Well, my second question is around the different languages. So universities that have Mandarin, Russian, or Sanskrit, or Hindi, do they have these same problems that the English-speaking ones have? ChatGPT, or
By what problems do you?
Well, I think professors probably think that some of their students have used ChatGPT to get assignments done and things like
Oh, I
that.
see.
So these universities that probably are not English language universities, so are there similar problems with students? Are they looking at students more regional?
Well, so I can't speak to the problems with students. I can answer the question, what do these models know about languages other than English? So if those languages other than English had a presence on the internet, ChatGPT picked a bunch of them up, some poorly, some less poorly. So it's called, in the field, it's called low resource languages, which means it's hard to find the text to train on. And there's all kinds of efforts, I noticed in the natural language processing community, to create models for those other languages. It's a tricky world. You need those billions of dollars actually to make the really good models, and but there is a bunch of work to find ways to augment them with more knowledge of more languages. And as a side effect, you get translation for free in them, and you can translate in all of them. So I don't know the answer to your question about the impact on students in the other languages. I actually I can't speak with any knowledge of how much all those languages exist in GPT, the OpenAI stuff, although I've had students from Ethiopia and China sit next to me and tell me whether the answers that come out in Amharic, or in one case, or Mandarin in the other case, was good. That the Mandarin was good, the Amharic was terrible. So, yeah.
So is it generally safe to say, do you think, that the smaller the language, quantitatively speaking, in terms of what exists out there on the internet, the less good these tools will be?
Yeah, absolutely. Yeah, those low resource languages. All the knowledge comes from the vast amount of writing in that language, textual writing. Yeah. This might be a little bit of an answer to your question. That is a thing that consumed me. When I was teaching my grad course for the first time, this was the question I didn't understand. I didn't understand, why does anything do what you ask it to do in English? And which it does, obviously, right? You do it and it asks it. And why does a thing that's predicting the next word based on what came before give you what you want? And the answer hit me, and maybe it's obvious. If there's a question in the text, then the right prediction of the next words is to try to answer it. And but before I thought of that, I was going, I don't understand why this is happening, until I go, okay. And that extra process that Sutskever talked about also makes it better at answering what you wanted it to answer. So the right prediction is a sequence of words that does answer the questions. it's kind of correct. Yeah.
I've noticed that I've asked ChatGPT a few times to predict something that hasn't yet happened. Like, which team will Otani side with? GPT says, I don't have real-time information. Yeah, do you think that it will at some point?
Yeah. So, will it have real-time information? Well, there's a way to do it. If you have the information that you want it to speak to, like a book, you can now take that book. It will cost you a fair bit of money. Throw that into the question, and then ask it. If you watch the GPT-4 rollout that Sam Altman gave, he threw in the American tax code into what's called the context, where you put the prompt, and then he asked questions that it got right about that. And so that's sort of one brute force way to do it. There's another method that's called retrieval augmented generation, where you go through another step. You have this thing you want. You've got a whole pile of possible things that might help, that are roughly about what you do, and you use those meaning and numbers thing to say, oh, this is like that. You pull it over, you stick it into the context, and then ask your question, and it produces the answer. This is it's got an acronym, RAG, Retrieval Augmented Generation, and I think the university is even trying to provide some version of that for you. If you had a whole website or a whole textbook that you wanted to have a thing that gave good answers on, you can it'll get easier and easier to do that. So it's one way to address the non-immediacy of the information. In fact, it's a really interesting question. There's two kinds of knowledge in these neural nets. There's what's trained into it through that whole process, and then there's what you give it. It's called contextual knowledge or learned knowledge. And the questions that have been showing up in the literature is, what happens if they contradict each other? Which one wins? And so people are playing around with that. It's complicated, interesting, and there's lots to happen on that front. Thanks, Ken. This is where I'm going to. It's the last topic, and this connects a little bit to what Sutskever was talking about. This is how I think of what's going on. When you send something into the model, it's looking at every word, and it's predicting the next word. And so I think of the things that you put into the model as the state of the model. It has no other state. If you took those words away, it doesn't know anything other than what it was trained. But there's this state that you're handing it, and it's generating word after word after word. But I think I've begun to realize that the state that it's in isn't really changing that much after it's started to generate a bunch of words. And so this is what I think about. I think that given what you've put into it, it infers one or more higher level concepts. And it's those higher level concepts that are guiding the generation word by word, and they're not changing all that quickly. As the words come out, maybe some other concept comes into play. And so it makes more sense to me to think about what's happening rather than just the thinking about the next word. There's this higher level inference. And so and one way you can see that is this gets pretty self-referential. We talked a moment ago about using the model to see if what came out of the model was correct, but you could also ask the model what it knows, and I find that a bit strange. And so you have to really make sure that it is, when you ask it what it's learned. So I asked it, what concepts are in this text, and it'll give you an answer. I pulled this random letter to the Globe and Mail out that's about, oil drilling in Africa, and this writer said that he was ashamed that this Canadian oil company is proposing to drill for oil in Namibia, even though it's an incredibly important World Heritage Site, and it poses a threat to the human rights of the local people and the environment and all kinds of things. And so you can ask GPT, list the 3 most important concepts that are implied or directly referred to in the text. And actually, I look at this, and it was actually pretty good. Environmental concerns, human rights and local impact, and climate commitments. I think there's really clear evidence that higher level concepts are being understood. So, yeah. These are more examples of it.
So what does the word understood
Yeah. What is?
I mean, we also talk about learned, and I'm not sure what that actually means.
Yeah, in the NLP field, actually, there's a bunch of arguments about what does it mean to understand, and what's the word they use. This is where the philosophers show up. And I watched Jeff Hinton give a keynote talk at the ACL conference, which is the Association of Computational Linguistics. It's one of the main computational language conferences, and he's in the camp that says the same thing, that it does understand because it infers higher level concepts. And he disagrees with the other camp that says, no, I can't remember it, that to understand is the subjective feeling of something. And I forget what that is. There's a whole philosophical side, and they go, no, that's not happening. There's no subjective anything here. But I think when I type something that is a specific instance of something that's far more general, and something can leap to that and work with it, I think that means understand. But it's a whole philosophical argument about what does it mean to understand. Hey, I'm going to end this video there. The discussion with that group went on for quite some time with lots of great questions. Unfortunately, the audio didn't pick up the questions so well, so I'll close it off here, but it was a wonderful discussion. I hope you found this video worthwhile.